Hi everyone, I'm Yuzhen from the University of Houston. In this talk, I'll present UniDiff, an unsupervised parameter efficient approach for adapting ImageNet pre-trained diffusion models to multimodal remote sensing data such as SAR and hyperspectral imagery. To motivate our work, let me start with a key triangle in multimodal remote sensing. Dense pixel-level annotation for land cover mapping is expensive and hard to scale, especially for hyperspectral and SAR imagery, where we usually don't have a large label dataset. However, most existing multimodal fusion methods are fully supervised and rely on the label data to learn the cross-modal relationships from scratch. As a result, their performance is limited by the label availability. At the same time, foundation models show that the large-scale unlabeled pre-training can learn the strong representations for downstream tasks. But these models are usually limited to a single modality and do not directly support the multimodal learning. So this leads to our key question: can we learn effective multimodal representations without labels and still perform well on the sparse annotation? To answer this question, our key idea is UniDiff. UniDiff learns effective multimodal representations through unsupervised adaptation. We use a diffusion backbone because its multi-noise training learns hierarchical spatially structured features that are robust to noise, which is especially important for texture-poor inputs like SAR and PC-reduced hyperspectral imagery. Starting from an ImageNet pre-trained diffusion model, we keep the backbone frozen and adapted in a parameter-efficient way by updating only small conditional layers. So by extending diffusion's internal conditionally from the time-step only condition to joint time-step modality condition, a single diffusion backbone can be dynamically adapted to multiple sensor modalities. This slide shows the UniDiff framework, which has two stages. Stage A is unsupervised adaptation stage. We start from an ImageNet pre-trained diffusion model and adapt it without labels. In standard diffusion models, the network is conditioned only on the diffusion time step. In UniDiff, we extend the conditioning not only on the time step, but also on the sensor modality, use lightweight thin layers. During continued pre-training, one key triangle is the catastrophic forgetting. To adjust this, we use two strategies. We apply parameter-efficient fine-tuning by freeze the diffusion backbone and make the thin conditional layers only trainable. We also include the procedural RGB as an ImageNet modality to stabilize the adaptation. Stage B is used only for evaluation. The adapted backbone is frozen and used as a feature extractor, and the lightweight classifier is trained with sparse labels for land cover mapping. Let me briefly summarize the key design of UniDiff. The core idea is joint time-step modality conditioning. Standard diffusion models condition only on the time step, while UniDiff also conditions on the sensor modality. To prevent catastrophic forgetting, freeze the diffusion backbone, update only the condition film layers, and use procedural RGB as an ImageNet-like anchor. So this allows our one diffusion backbone to adapt across modalities without forgetting the pre-trained prior. We evaluate UniDiff on two standard multimodal benchmarks, Berlin and Augsburg. Both combine hyperspectral and SAR imagery. We follow the official trend test spreads, use less than 1% pixel level labels for training, with dense annotation used only for evaluation. Here are the main quantitative results. UniDiff consistently improves overall accuracy on both Berlin and Augsburg, outperforming our state-of-the-art supervised multimodal baseline with identical inputs. This shows that unsupervised adaptation in UniDiff runs strong multimodal representations that works well for downstream tasks, even when the training labels are sparse. Here we show qualitative results on the Berlin dataset. Even with less than 1% training labels, UniDiff produces the clean boundaries and coherent land cover regions. We observe similar qualitative behavior on Augsburg dataset. Thank you for your attention. The code available via the QR code.